Okay, so today we're going to be talking about digital imaging, and this is on chapter 25 of your dental radiography textbook. So the learning objectives for this chapter are to define the key terms associated with digital imaging, also to describe the purpose and use of digital imaging, and discuss the fundamentals of this type of imaging. Also describe radiation exposure, list and describe the different equipment used, as well as describe the two types of digital imaging. We'll also describe the patient and equipment preparations required and list and discuss the advantages and disadvantages of digital imaging. So in dental imaging, advances in technology have resulted in a unique filmless system known as digital imaging. And the purpose of this chapter is to present the basic concepts of digital imaging, to introduce the various types, and to discuss advantages and disadvantages of this form of imaging. So the basic concepts that we'll be going over is that digital imaging is a technique used to record digital images or dental images. And unlike conventional dental radiography techniques discussed in the previous chapters, no film or processing chemistry is used. Instead, digital imaging uses an electronic sensor as well as specialized computer software that produces images almost instantly on a computer monitor. So some of the terminology we'll be using is an analog image, which is a radiographic image produced by conventional film, a bit depth image, which is a number of possible grayscale combinations for each pixel, a charge coupled device or CCD device, which is a solid state silicone chip detector that converts light or X-ray photons into an electrical charge or signal. Digital imaging just means filmless imaging system, and digital image is an image composed of pixels that can be stored in a monitor, or excuse me, in a computer. Digital subtraction, which is one feature of digital imaging, such that a method of reversing the grayscales as an image is viewed. And to digitize is in digital imaging to convert an image into a digital form that can be processed by a computer. Direct digital imaging refers to a method of obtaining a digital image in which an intraoral sensor is exposed to radiation to capture a dental image that can be viewed on a computer monitor later. Indirect digital imaging refers to a method of obtaining a digital image in which a sensor is scanned following exposure to X radiation and then converted into a digital form that can be viewed on a computer monitor. Line pairs slash millimeter, which can look like LP over MM, is a measurement used to evaluate the ability of the computer to capture the resolution of an image. A pixel is a discrete unit of information, and a sensor is a receptor that is used to capture an extraoral or intraoral image. A storage phosphor imaging is a method of obtaining a digital image in which the image is recorded on a phosphor-coated plate and then placed into an electronic processor or an electronic scanner. The purpose of digital imaging is to generate images that can be used in the diagnosis and assessment of dental disease. Other uses include the following: to detect lesions, diseases, and conditions of the teeth and surrounding structures, to confirm or classify suspected disease, to localize lesions or foreign objects, and to provide information during dental procedures. The images produced are diagnostically equivalent to or better than film-based images, thus enabling the dental radiographer to see conditions that cannot be seen or identified clinically. Other purpose and uses is to evaluate the growth and development, to illustrate changes secondary to caries, carries periodontal disease or trauma, to document the condition of a patient at a specific point in time, and to aid in the development of a clinical treatment plan. So digital images present similar information as film-based image, just a lot faster and a lot better. So the term digital imaging refers to a method of capturing an image using a sensor, breaking the image into electronic pieces, and presenting and storing the image using a computer and imaging software. So a digital image is an image used to describe the pictures that are produced, and a sensor is placed inside the mouth where the electronic signal is digitized. Digital imaging requires less radiation exposure than film-based imaging. Less X radiation is necessary to form a digital image on the sensor because the sensor is more sensitive to X radiation than is conventional film. So depending on the speed of the film or the speed of the sensor that is being used, exposure times for digital imaging are 50 to 90% less than those required for conventional radiography. For example, the typical exposure time required to produce an image for digital imaging is about 0.05 seconds. This exposure time is much less than the 0.2 seconds required for intraoral film used in conventional radiography. The equipment that you'll be using for digital imaging is a regular X-ray unit, a sensor, and the sensor can either be can be one of the two types, can be a charged coupled device or CCD, or a complementary metal oxide semiconductor or an active pixel sensor. Also, you will need a computer in which to connect your sensor to. So a CCD is a solid state detector that contains a silicon chip with an electronic circuit embedded in it. Most digital imaging systems use a conventional dental X-ray as the X-ray radiation source. And just remember, the X-ray unit timer has to be adapted to allow exposures in a time frame of about 1/100th of a second. So when we look at a control panel of an X-ray unit, 1/100th of a second refers to that 0.08 or that 0.06 that we sometimes see. So that would be 6/100ths of a second or 8/100ths of a second. And just remember, a standard X-ray unit that is adapted for digital imaging can still function for conventional imaging. We just have to change the exposure settings. A sensor is a small detector that is placed in the mouth of the patient and used to capture the radiographic image. They can either be wired or wireless. In a wired case, the imaging sensor is linked by a fiber optic cable to a computer. In a wireless sensor, the imaging sensor is not linked by a cable and is usually connected by some type of wireless source like Bluetooth or Wi-Fi. And most manufacturers produce sensors similar in dimension and size to intraoral films, such as 0, 1, 2, and size 4. So most popular types of direct sensor technologies include a charge coupled device or the complementary metal oxide semiconductor / active pixel sensor. Both are rigid solid-state detectors made of silicone that are arranged in an array of X-ray sensitive pixels. A charge-coupled device is a common receptor used in digital imaging. The CCD is a solid-state detector that contains a silicone chip with an electronic circuit embedded in it. And the electrons that compose the silicon chip in the CCD can be visualized as being divided into an arrangement of blocks or picture elements known as pixels. And a pixel is a small box or well into which the electrons produced by the X-ray exposure are deposited. The X-ray photons that come into contact with the CCD cause electrons to be released from the silicon and produce a corresponding electronic charge. Consequently, each pixel arrangement or electron potential well contains an electronic charge proportional to the number of electrons that reacted within the well. Furthermore, each electronic well corresponds to a specific area on the linked computer screen. Okay, so that what I just said goes along with this slide here. And this just saying that with each pixel arrangement or electron potential well, there is an electronic charge proportional to the number of electrons that reacted within the well. And each electronic well corresponds to a specific area on the linked computer screen. A complementary metal oxide semiconductor / active pixel sensor, also known as a CMOS or APS, is when a manufacturer uses a chip that is less expensive to produce and offers greater durability than a CCD. And CMOS sensors can be connected to a computer using a low power external connection such as a USB. In digital imaging, a computer with imaging software is used to store the incoming electronic signal. The imaging software is responsible for converting the electronic signal from the sensor into a shade of gray that is viewed on the computer monitoring. The imaging software digitizes, processes, and stores information received from the sensor. And an image is recorded on a computer monitor in 0.5 to 120 seconds, which is far less time than required for conventional film processing. Also, various computer viewing features are available with digital imaging software, where digital systems feature split screen technology, which allows the operator to view and compare multiple images on the screen. Okay, so this feature is helpful for comparing and for evaluating the progression of caries or periodontal disease. So for example, by comparing previous to current bite wing images. So the speed of the image recording is extremely useful during certain dental procedures. And images may be sorted permanently in the computer, printed on the hard copy for the patient record, or transmitted electronically to insurance companies or referring dental specialists. So there are two methods of obtaining a digital image currently. So one is by using an indirect digital imaging, and the other is by using indirect digital imaging, which includes scanning traditional images or storing on a phosphor plate. With direct digital imaging, the components include an intraoral dental X-ray unit, a sensor, and a computer with imaging software. And this is when a sensor is placed into the mouth of the patient and exposed. And the sensor then captures the image and transmits it onto the computer monitor. Software is then used to enhance and store the image. With indirect digital imaging, the components will include a CCD camera and a computer. This is when an existing X-ray film is digitized using a CCD camera. And this allows the image to be displayed on a computer monitor. This concept is similar in theory to scanning an image, such as a photograph, to a computer screen, where the image is similar to a copy of the image versus being the original. So a storage phosphor imaging is when we use a wireless digital, it's basically a wireless digital imaging system that uses a reusable imaging plate coated with phosphors instead of a sensor with a fiber optic cable. And the phosphor coated plates are flexible and fit into the mouth, much like a conventional film does. And a high speed scanner is used to convert the information into electronic files. And this type of digital imaging is less rapid than direct imaging because of the fact that we have to process all of the images, much like processing film, except when we process film, we place it into tanks of different chemicals. And when we process phosphor imaging, we're basically just inserting these phosphor plates into something that looks like a scanner. Some step-by-step procedures will just include preparing the intraoral sensor and then placing the intraoral sensor. And it's very important to refer to the manufacturer's instructions so that you don't mishandle the type of sensor that you're using. So like I said, it's critical to refer to the manufacturer provided instruction booklet for information concerning the operation of the system, equipment preparation, patient preparation, and exposure. So each sensor is sealed and waterproofed. Um, Digital imaging involves the placement of the intraoral sensor in the mouth of the patient using the same technique as film-based imaging. Whether using indirect or direct digital imaging, it is important that the individual sensors be protected from oral fluids. A PSP plate is placed in a disposable barrier sleeve that is waterproof. Rigid digital sensors, wired or wireless, must be covered with a disposable barrier sleeve. And a rubber finger cot may be placed underneath the disposable barrier sleeve to further protect the wired or wireless sensor and to prevent cross-contamination between patients. The intraoral sensor placement is when the sensor is held in the mouth by bite block attachments or devices that aim the beam and sensor accurately. The book says that the paralleling technique is the preferred exposure method. However, you can still use the bisecting technique, and it still works well here. Some of the advantages of digital imaging are that number one, we get superior grayscale resolution, we get reduced exposure to radiation, we have increased speed of image viewing, lower equipment and film cost, increased efficiency, enhancement of diagnostic images, effective patient education tools, and it's an eco-friendly tool because we're not using having to buy disposable materials for this. So digital radiography uses up to 256 colors of gray compared with the 16 to 25 shades of gray differentiated on a conventional film. And the ability to manipulate the density and contrast of the image without additional exposure to the patient is also an advantage. Also, the exposure of digital radiography is about 50 to 80% less than that required for conventional radiography. The nice thing is that the images are able to be viewed instantaneously, no film costs or disposable costs are necessary. And it's a greener alternative because it doesn't use any chemical processing or generate any hazardous waste materials. The disadvantages of digital imaging is that its initial setup costs are relatively high compared to simply buying films and developing chemicals. Also, sometimes the image quality can be less depending on the type of sensor that you're using. Sensor size and thickness is also thicker and less flexible than intraoral film. Also, infection control can be an issue since we are using the same sensor for all patients. We have to be very careful to keep not only to keep the sensor clean, but to always use a protective barrier so that we don't cross-contaminate any patients. Also, wear and tear is an issue because as the sensor is used multiple times for multiple patients throughout a certain or a given amount of time, wear and tear can happen. And these sensors are very expensive, way more expensive than simply buying a box of film. And so that's just another disadvantage. The other disadvantage are legal issues. Because the original digital image can be enhanced, it is questionable whether it can be used as evidence in court. All right, that's it for this chapter. Please email me with any questions or ask me in class. Thanks, and we'll talk next time.